Imagine this. It's August 6th, 2025, a day that will go down in the annals of astronomy as a turning point in our understanding of the universe. The James Webb Space Telescope, JWST, humanity's most advanced eye in the sky, suddenly shifts into emergency mode. No, this isn't a drill or a minor glitch. It's a frantic scramble to lock onto an interstellar intruder that's defying every expectation. Astronomers had braced for a routine sighting of a fading icy wanderer from beyond our solar system. But what JWST captures isn't just another comet, it's a chemical enigma wrapped in a cosmic riddle. The coma of 3I/ATLAS is bursting with carbon dioxide at unprecedented levels, and it's laced with metallic nickel. Yet there's not a whisper of iron to be found. This isn't your everyday space rock. It's shattering the rules we've written for comets, leaving experts stunned and whispering about possibilities that sound straight out of science fiction. As the data streams in, the implications hit like a meteor shower. Is 3I/ATLAS truly a natural formation, born in the frigid depths of some distant star system? Or could it be something more? Something engineered hurtling toward us with intent? The tension builds with every new revelation, and trust me, you won't want to miss a single detail. Stick around until the end, because we're diving deep into the science, the history, and the wild theories that could rewrite our place in the cosmos. This is the story of 3I/ATLAS, the comet that refuses to play by the rules, and it's only getting more mind-blowing from here. Let's set the scene properly to hook you right in. Picture the Mission Operations Center at NASA's Goddard Space Flight Center, usually a hub of methodical calm where scientists meticulously plan observations months in advance. But on this fateful day, at precisely 2:11 GMT, a urgent call pierces the quiet. It's Marco Macchi, a lead astronomer from the European Space Agency, ESA, his voice tight with urgency. The preliminary data from ground-based telescopes like Pan-STARRS and Gemini South has just dropped, and it's alarming. 3I/ATLAS isn't just passing through, it's accelerating in ways that don't add up, its spectral signature flickering with unexpected metals. There's no room for hesitation. The window to observe this enigma is slamming shut. In under 6 minutes, the override command is greenlit and uploaded to JWST. This isn't a casual pivot. It's a rare emergency maneuver that halts the telescope's entire scheduled science program. Think about it. JWST's orbit is a delicate dance, balancing fuel efficiency with groundbreaking discoveries. Every second counts, and overriding the queue risks derailing weeks of research or even damaging subsystems. Yet the stakes are too high. Since its launch in 2021, JWST has only executed a handful of such overrides, fewer than 4 in total, and none for an interstellar object like this. The decision chain shoots straight to the project scientist, requiring unanimous approval. Why the rush? Because 3I/ATLAS's trajectory is evolving by the hour, its coma expanding with volatile gases and mysterious metallic hints that scream for immediate scrutiny. Michelle Thaler, a key figure in NASA's communications and an astrophysicist with years of experience, takes the helm on calculations. Running simulations on ESA's powerful servers, she nails the precise coordinates. JWST's near-infrared spectrograph, NIRSpec, must slew into position swiftly, capture the spectra, and beam it back before the comet slips away. At 2:17 GMT, the command executes. The telescope pivots, its instruments humming to life as teams monitor the telemetry for any hiccup. In the control room, hearts pound as the first raw data packets arrive. There it is, the core of 3I/ATLAS glowing fiercely against the cosmic backdrop, a beacon of the unknown. The shift log entry is deceptively simple. 2 override 3I/ATLAS, 6 August 2:17 GMT NIRSpec. But behind those words lies a high-stakes operation with zero margin for error. As the data stabilizes, the real shockwaves begin. What JWST uncovers in those initial moments dismantles decades of comet science. And folks, if you're intrigued now, keep watching, because the chemical bombshells are about to drop, and they could change everything we think we know about the universe. Diving into the chemistry, the first red flag waves high. Carbon dioxide dominates the spectrum in ways no one anticipated. At 6 astronomical units, AU, from the Sun, way out past Jupiter, where sunlight is a feeble whisper and most comets remain dormant, 3I/ATLAS is already erupting with activity. Ground telescopes like Gemini South had hinted at a faint brightening, not a transient flare, but a steady glow. Then confirmation rolls in, tails extending like ethereal appendages, days before crossing Saturn's orbit. That's not standard comet behavior. Typically, solar system comets awaken closer in, around 3 astronomical units, when water ice sublimates into gas. But here, carbon dioxide is the star of the show, with JWST measuring an astonishing 8-to-1 ratio to water. Let that sink in. For context, typical comets max out at about 0.7 CO₂ to water. Even 2I/Borisov, the previous interstellar visitor discovered in 2019, clocked in around 0.5. This is off the charts, a chemical outlier that screams different origins. NIRSpec captures the NU3 band at 4.26 microns. Strong, broad, impossible to miss. Water is there, but it's a mere whisper compared to the CO₂ torrent. Production rates show CO₂ outpacing water eightfold, with dust minimal, rendering the Comet translucent and the tail spectral. Cross-checks from Hubble Space Telescope, HST, SPHEREX, and others align perfectly. No artifacts, no errors. The data is solid. Bryce Bolin, a comet expert who's dedicated years to studying these interstellar nomads, sums it up eloquently. Every interstellar comet is a messenger from another star system. By analyzing their light and composition, we glimpse the diversity of worlds beyond ours. But 3I/ATLAS's message is bizarre. A body rousing in the outer solar system's deep freeze, expelling CO₂ like a hidden volcanic vent. This points to a birthplace unlike our own, perhaps a system where water is rare, or CO₂ ices dominate, or maybe an unseen process, one that forces us to rewrite comet formation theories. Imagine a world-building factory gone awry, churning out these oddballs. The tail's rapid growth, spanning hundreds of thousands of kilometers in days, defies physics for such distances from the Sun. The ratios don't match any known comet, not even the eccentrics like Hale-Bopp or Hyakutake. As teams pore over the data, the anomalies multiply, building a case that's impossible to ignore. But hold on, this is just the beginning of the chemical weirdness. The real jaw-dropper lurks deeper in the spectra, and it's about to send ripples through the scientific community. If you're hooked on this cosmic thriller, don't click away yet. The metallic mystery is next, and it ties into ancient human history in ways you won't believe. The spectra from JWST and supporting telescopes like the Very Large Telescope 5LT reveal nickel lines popping up almost instantly after lock-on. At first, skeptics dismiss it as a glitch, perhaps instrument noise or a cosmic ray interference. But rigorous checks confirm nickel transitions are crystal clear across ultraviolet and near-infrared wavelengths. At 3.8 astronomical units, nickel production hits 10 to the 21st atoms per second, surging another order of magnitude by 2.85 astronomical units. That's prolific for any comet, but the kicker? Iron is utterly absent. VLT's UVES instrument, with its 80,000 resolving power, scans every iron channel. Nothing. Upper limits peg nickel outnumbering iron by over 40-to-1. In solar system comets, nickel and iron pair like cosmic buddies, adhering to ratios of about 1:15. Borisov followed suit, but 3I/ATLAS flips the script. It's like discovering a treasure chest full of gold but no silver, utterly anomalous. Specific lines at 3,415, 3,524, 3,525, 3,769, 3,783, 3,870, and 3,858 angstroms stack up with signal-to-noise ratios exceeding 30, while iron channels remain silent. Teams at ESO and JWST dissect the data line by line, ruling out contamination or solar interference. One theory emerges, nickel carbonyl, NiCO4, a volatile compound that vaporizes at 43 degrees Celsius. In CO-rich ices under UV light, it forms and releases atomic nickel upon breakdown. Iron pentacarbonyl, Fe open parenthesis. CO close parenthesis 5, however, is less volatile, explaining its silence. This suggests a formation environment favoring nickel, sidelining iron, unprecedented in any volatile-rich body. No solar system comet shows this. It's a fingerprint of alien chemistry. As the puzzle deepens, old models crumble. What stellar nursery could birth such a freak? Is it natural evolution or something more intentional? The questions mount, pulling us toward the motion anomalies that amp up the intrigue. Stay with me. This is where it gets even wilder. Beyond composition, 3I/ATLAS's movement raises eyebrows and alarms. Pan-STARRS trackers note its trajectory, veering off predicted paths. Over 72 hours, velocity spikes by 0.12 meters per second squared, far exceeding solar heating or outgassing effects. For an 11-kilometer object, that's like a mountain suddenly sprinting. Deviations aren't smooth gravitational arcs but jittery jumps, as if intermittent forces pulse within. Astrometry holds firm after double checks. Light curves from Gemini South and TESS show periodic brightening every 7.2 hours. Too precise for a tumbling rock. Models for irregular shapes fall short. Suggestions of hollow or sheet-like structures emerge, but problems persist. Outgassing should slow spin, yet the period locks in as activity intensifies. Echoes of 1I/Oumuamua abound. That 2017 visitor accelerated oddly too, sparking debates. But 3I/ATLAS is larger, brighter, its curve more mechanical. Parallels fuel speculation. Cosmic oddity or artifact. Pan-STARRS archives feed global debates, preprints buzzing with theories. As observations accumulate, science fiction edges into reality. But to grasp the full weight, we must journey back millennia, where humanity first encountered nickel-rich skyfallers. This historical thread adds layers of wonder. Keep watching, because the past holds clues to this present enigma. Flashback 5,000 years to ancient Egypt, where artisans craft iron beads before smelting technology exists. Tombs like those at Gersa yield pitted cylinders, analysis revealing 30% nickel, a ratio impossible for earthly forges. Only meteorites deliver such bounty. Manchester Museum samples confirm this cosmic origin. Tutankhamun's dagger, pristine after 3,000 years, boasts 11% nickel and cobalt traces, matching iron meteorites' Widmanstätten patterns. Across the Near East, royal artifacts echo this. Nickel-enriched blades from heavenly gifts. Babylonian tablets warn of burning stars and raining stones. Omens of change. The word anbar for iron ties to rituals warding celestial dangers. Historian Lydia Baum at Heidelberg notes the fear woven into texts. Sky metal heralds transformation. Egyptians dubbed it iron from heaven. Babylonians saw portents of war. They couldn't know the chemistry, but their reverence and dread mirror today's awe at 3I/ATLAS. Modern scans of ancient iron revive that echo. Unexplained visitors from above, feared and revered. The puzzle spans eras. What omens does 3I/ATLAS bring? Harvard's Avi Loeb doesn't mince words. In a September 10th, 2025 blog, he highlights the nickel-iron imbalance, acceleration, and clockwork curve. What natural process achieves this? Labs separate metals industrially. Cosmos shouldn't. Loeb's Oumuamua work stirred pots. Now 3I/ATLAS amplifies it. Teams split. Some favor exotic chemistry from carbon-rich nebulae. Iron-bounded minerals, nickel volatile. Others eye engineering parallels like light sails riding photons, explaining motion and glints. No proof, but the idea is viable alongside natural models. NASA's Planetary Defense Office flags it as a high anomaly, tracking via risk matrices, usually for impactors. Official stance: cautious, needing more data. Debates rage in forums, dissecting spectra and curves. Recent updates as of September 21st, 2025. Add fuel. SphereX detects CO2 fog enveloping 3I/ATLAS, and during the September 15th lunar eclipse, it glowed green, eerie, captivating. Perihelion looms October 29th at 1.36 astronomical units. What revelations await? So is 3I/ATLAS a fluke, a chemical messenger, or evidence of extraterrestrial tech? Discovered July 1st, 2025 by Atlas, it's the third interstellar object after Oumuamua and Borisov. JWST's August 6th override unveiled 8-to-1 CO2 to water, nickel-sans iron defying models. Accelerations in brightness defy gravity, echoing ancient skyfall fears. Experts divide, some invoking unknown physics, others artificial origins. Classified docs label it anomalous, behavior unexplained. It fits no category. As data flows, the cosmos's secrets unfold. What does this mean for us? The question lingers, urging deeper exploration. Thanks for watching to the end. Subscribe for more cosmic mysteries and share your theories below. The universe is full of surprises. Let's uncover them together.